So we're group number 5, and we're working on improving bicycle brakes. In our group, we have Taylor, myself, Chris, Peter, Juliana, Shahid, and Alir. So what we're focusing on is improving the safetiness of brakes. One of the main problems with that people occur when they're bicycling is braking hard and running into risks where if they brake too hard on the rear brake, they may skid, where the bike continues moving, but the wheel is stopped, and so they lose control. Another problem is that they may slam on the front brake too hard, and then that poses a risk of flipping over the bike. So our system detects how safe the bike is and what the orientation of the bike is, and from there we can determine when to engage and disengage brakes in order for the cyclist to return back to a safe position.
Cool. And the way we do this is we take a couple of inputs from the way the bike is actually moving and the state of the bike. These inputs are basically an accelerometer, a gyroscope, a pair of rotation sensors on the wheels, and what else do we have? Oh yes, and the state of the braking system itself, if you will. So once we have those inputs, we can determine the tilt of the bike, whether or not the bike is decelerating, whether or not each wheel is moving, and whether or not the braking system mechanism itself, if you will, is where we want it to be. Once we have those inputs, we run it through decision logic in a computer, and what this decision logic determines is whether or not the brakes are acting like they should, whether or not the person is safe with the brakes acting the way they are currently, and therefore whether or not we need to take force off the brakes and let the wheels continue spinning. Once we have determined whether or not we need to release the brakes, and if we do release the brakes, what we do is, you should probably look down for this, the computer sends a signal to a very high voltage power supply, if you will, that sends current to these motors on the back of this plate here. These motors attach to these cams right here, and what these cams do is they rotate against this cable. And while they're rotating against the cable, the first thing they do is they release tension on the cable. This is the brake cable, so once the tension is released, the brakes will sort of snap away from the wheel, and this allows the wheel to start turning again once it's not under any force. And if it happens to be the case that the person's tilting, this actually allows the person to return back to normal tilt as well. So once the brake cable has been released for just a little bit, the cam will continue rotating under the power of the motor, and once it does, it will go back into this state once again where the where the cable is tense. Once it's at this tension again, the system goes, okay, the cam is where it's supposed to be. Is everything safe for the user? If it isn't safe and they're still, flipping over, or if the wheels are still skidding, then it continues turning the cam over and over again until it is safe. And once it is safe, we stop turning the motor and everything returns back to normal for the user. That's effectively how it works. This cycle repeats about 5 times every second, so it feels almost like a normal ABS in a car. Unfortunately, the demo didn't really work out because we couldn't get a motor powerful enough to do that, but alas, it's what we have, and we're quite happy with it. We think it would be a great benefit to the safety of the people using the bicycle brakes. So, yeah, thank you very much.